Hello everybody, this is Michael. In this video we will talk about the Wi-Fi chip ESP8266. For the past few years this chip is very popular and there is lots of projects and applications built on this chip. So let's take a look at the chip's features and why it is so popular. So this is the data sheet for this chip. Before we go into the chip details, I like to take a look at these things. So package information. So this is the package information for the chip. You will see this chip is 5 by 5 millimeter. So 5 by 5 millimeter is very small, so which means you can design a small devices, and it is very important for our portable devices or internet things devices. We always want to design it as small as possible. At the same time, you will see here. So this is a QFN package. So you can easily wire out all the pins, all the traces which you need. So it will significantly reduce the design effort, design difficulty, and also the cost of the board. And so maybe you can just use 2-layer PCB design to achieve your target. So this is very important. And some other Wi-Fi chip using the BGA package, which is increase the difficulty and also increase the cost. And so some others package is also quite big compared to this one. So let's go back. Take a look at the basic information for the chip. Overview. So for these things, you will take a look here. So it integrates antenna switch, RF balloon, power amplifier, and no noise receive amplifier filters and the power management module integrate into the same chip. So it means you no need to edit all the circles anymore. So it further reduce the design effort and reduce the board size. So the design minimize the PCB size and require minimal external circuits. And this is first thing. So the second thing, Wi-Fi protocol. Of course it is a Wi-Fi chip, so it supports lots of Wi-Fi protocols, something like this, and station mode, and P2P mode, and soft AP mode. So this is the second thing. So you will see the specification here. For the specification, we will interest in these things. So antenna, first thing, antenna. So it can use PCB trace and also chip antenna. So PCB trace, it means you can just use the PCB trace, will reduce the BOM cost. And the chip antenna, it will significantly reduce the board size and make your devices as small as possible. So this is third thing. And let's take a look at the next one. So this is application for the chip. Very interesting things. You can design the IP camera. You can design the sensor network, wearable electronics, and even the baby monitor. Okay, let's take a look. Another thing. So this is a pin definition. So for the pin definition, you will see this is 32 pins. This is the in the middle pin. Okay, it connected to the ground. So we will take a look. They describe the pin here, detail information here. But we take a look here is a more global view of the function of the chip. Okay, so what kind of interface it have? UR, of course. Lots of chip have the UR. It can communicate with other microcontroller or FPGA or DSP. GPIO, yes, GPIO. So is a feature of the lots of chip, and I2C, I2S, SDIO, and PWM, and ADC, and SPI, and Flash. Okay, so it support all of the interface, and we can use this interface to communicate another microcontroller, or communicate or control other sensors devices, to communicate, to read the data and send the data, go through the Wi-Fi network. Okay, and you will see here it also integrate SRAM. Okay, so this is SRAM. Okay, so and this is RF. All the RF circles inside the chip make the whole design is as small as possible. Okay, so let's go continue. So this is this feature is very interesting. It's a CPU integrate 32-bit processor, and the maximum hertz is 160 megahertz. Okay, and so what's mean about the integrate CPU? So it means the single chip. Okay, the single chip, you can program it, you can control the, you can run the your customized software on the chip and control other devices. And also this high performance chip is over 160 megahertz. It means has the ability to processing some time, processing some data in real time. Okay, so it's a powerful CPU integrate into the chip. Okay, and if you using maybe you already using some other Wi-Fi modules, it only can communicate with your microcontroller by the UR or other interfaces, or like SPI, but it cannot program by itself. So it for this chip, it has the microprocessor, and you can program your customized software in it. Okay, next thing, so is memory. Memory, it integrates SRAM into the memory, and you can have the external flash. The external flash save your old software into the SPI flash. Okay, let's continue. Okay, this is clock. The clock, you need to pay attention just one things, maybe two things. Is the first thing is minimal and maximum. Okay, the second thing is the tolerance. Between this tolerance and between the minimum and the maximum, it will be fine. Okay, And let's continue. Maybe we don't take up too much effort to take a look at this. And so this is power management. Power management, we needed to focus on a few things like this. So it can have 3 modes: active mode, sleep mode, and sleep mode. Okay. So when your device is not in the working mode, which means active mode, we usually put it into the deep sleep mode to save the battery, and so your devices can work as long as possible. And we take a look here, consuming about 20 microamp of power in deep sleep mode. So it's a very small carrying consuming. It's a very small carrying consuming, and so we can use a battery to power it, and put the devices in deep sleep mode in the most of time. When we need to send the data, we wake it up and send the data out. Okay, and this RTC is still running. It has a real-time RTC. Okay, so this is a power management switch, status switch, deep sleep. Okay, wake up and work. Okay, let's continue. So for this chat, it is detail describe about the GPIO. Okay, so about the interface. So first one is the GPIO. It has 70 GPIO. Okay, so the second thing, let's take a look. So this is SDIO. What's mean about these things? SDIO, you usually will see it into the SD card. It's very popular into the SD card. Okay, for the SDIO, the important thing is the speed is very high. Okay, 25 megahertz, 4-bit. So you can transfer your data from the microcontroller or from FPGA to the Wi-Fi chip by SDIO. It can achieve like a 100 meg bit data rate. 4-bit 25 megahertz is means 100 meg bps. Okay, so this is a high speed interface for the communication. Okay, with other chip. Okay, so SPI. So the first, see, it has a 3 SPI. It's wonderful. SPI is also a kind of high speed. Okay, and they have 3 SPI. There's lots of sensors using the SPI to communicate, and we also can use the SPI to control the microphone, to receive some digital microphone data and then send it out by the Wi-Fi. Okay, it has 3 SPI. Okay, so this is general SPI and slave SPI. I2C interface. Okay, and I2C interface, the great benefit for the I2C interface is 2 cable, 2 trace can control lots of I2C devices, as long as the I2C devices has a different address. Okay, so this is a pin number for the I2C. Oh, the wonderful thing is we have this chip have the I2S interface. I2S interface is particularly for the audio, and you can connect an audio codec to play the music through the I2S interface, and also you can connect an I2S microphone to stream the audio go through the Wi-Fi. So it's like a Wi-Fi phone. You can design a Wi-Fi phone by the I2S interface with this chip. Okay. UR is a very normal. It has two UR. Okay, it has two UR. It's a very normal interface. But the important thing you will see here, the UR speed is very high. Okay, 4.5 Mbps. Okay, so actually it's quite different from other microcontroller, from other chips. Okay, it also supports the PWM function, pulse width modulation. It has 4. That's wonderful. It has 4 PWM output interface. PWM interface it can use to control the motor, control the, many other things, and so it's very useful for some application. Okay, this thing is IR remote control. This is an infrared remote control interface. This is very interesting. You can use it to decode your TV controller, remote controller. Okay, so like if you can use your TV controller to control the Wi-Fi chip to read sensor data and then send it out by Wi-Fi. So it's very interesting application. Another thing is ADC. ADC we can use it to monitor the power supply voltage. Okay, so here we can use it to monitor the power, the battery, to see the battery still have the power or not. We also can measure the input voltage of this pin. Okay, so it means you can measure some analog signals. Okay, and so LED light and button. So you can use any GPIO to control the LED and buttons. Is no problem. There is a 17 and 17. Take a look at this power consumption. So this is a list for the devices. How much power the currents it will consume during different status. You will notice the two things. So one thing, the speed different, the power consumption, the current is different. See here, and if your project, if your devices don't need to send lots of data, you can set the package like this, 1K. Then you will get a much better power consuming performance compared to use this. So we need to setting different working more for these devices, and we will get a different battery performance. Okay, so we already talked about this deep sleep. So it is like a 20 microamp. Okay, so this is Wi-Fi radio characteristics. Okay, this is the last things we already discussed it before. Okay, accept all the detail about the this is Wi-Fi chip. The most important thing is that why this chip's price is very low, and you can easily access all the information, including software, and you can get lots of support from the community of this chip. We try to record more videos about this chip, and to help people to use it, because it's a really wonderful and interesting Wi-Fi chip. Okay, that's it, and this is Michael, and hope you will support